Come back. Let's continue with example 2. Find limit x approaching infinity e to the power x over x cubed. Notice this is of indeterminate of the form of infinity over infinity. So we can use L'Hopital's rule. Okay. But in this case, we will have to apply L'Hopital's rule repeatedly. Why? Let's see. Take derivative once. Derivative of e raised to x is itself. Derivative of the denominator is 3x squared. Now this is again infinity over infinity. So continue with L'Hopital's again. Derivative of the top, derivative of the bottom. This is also indeterminate of infinity over infinity form. So take derivative once more, e raised to x over 6. Now this is simply positive infinity. Next, limit x approaching infinity natural log x over x cubed. Now this is indeterminate of the form infinity over infinity. So we'll have to use L'Hopital's rule. We might have to apply it repeatedly. Let's see. Do we have to? X approaching infinity, natural log x over x cubed is infinity over infinity. Take derivative of the top, 1 over x. Derivative of the bottom, 3x squared. So in all, limit x approaching infinity of 1 over 3x cubed, which is simply 0. Okay, I didn't have to take derivative more than once. Next, x approaching 0 of sine hyperbolic x minus x over x cubed. Sine hyperbolic x, so as x approaches 0, this goes to 0. This goes to 0. So numerator is 0 minus 0, 0. Denominator is also 0. So this is indeterminate of the form 0 by 0. We need L'Hopital's rule. So x approaching infinity, sine hyperbolic x minus x over x cubed is taking derivative. Derivative of sine hyperbolic is cosine hyperbolic. Derivative of x is 1. Derivative of x cubed is 3x squared. Now, when I take x approaches 0, this gives me 1. 1 minus 1 is 0. And denominator gives me 0. So, it's still indeterminate. So, I need to take derivative once again. Derivative of cosine hyperbolic is sine hyperbolic. Derivative of 3x squared is 6x. Now, let's look at limit x approaching 0. This is still indeterminate. 0 over 0. So take derivative once more. Cosine hyperbolic over 6. Now when x approaches 0, that gets me 1. This is constant. So answer is 1 over 6. Now, sometimes we encounter indeterminate products. We encounter limits of product functions fx gx as x approaches a, where the result is indeterminate of the form 0 times infinity. So which one is more valid, the 0 part or the infinite part? We don't know, right? So this is indeterminate of the form 0 times infinity. This can be converted to the form of 0, 0 or infinity by infinity. Well, what do? F times g, take any one of them and take its reciprocal downstairs. You see, f over 1 over gx is same as f x gx. What's the advantage? If f was going to 0 and g was going to infinity, now you have 0 over 0 form. Okay? If f was going to infinity and g was going to 0, then this is now infinity over infinity form. So you got our known form. So we can then apply L'Hopital's rule. So for example, find limit x approaching 0 from the right hand side of x squared natural log x. On the right hand limit x approaches 0. So when x approaches 0, this goes to 0, whereas this goes to negative infinity. So this is indeterminate. So we need to change things. Rewrite this as take that x squared and take its reciprocal downstairs. Now when x approaches 0 from the right, numerator goes to negative infinity, Denominator goes to positive infinity. Either way, this is indeterminate form of the type infinity over infinity. Well, so what do we do? By the way, you could have taken reciprocal of natural log downstairs. Okay, you'll get similar answer. I just chose x squared. It doesn't matter. So derivative of the top is 1 over x. Derivative of the bottom is negative 2 over x cube. You see, flip this. So this is division by a fraction. So x cube comes up, 1 over x is down. When you simplify this, it is negative x squared by 2. Now when you take limit x approaches 0 from the right, this simply goes to 0. So this actual limit is 0. Likewise, x approaching infinity, x squared e raised to x. Aha, look at that. X is approaching positive infinity. So this is infinity, this is infinity. Infinity times infinity is a bigger infinity. So it's actually infinity. You don't need to use L'Hopital's rule. It's straightforward. So you see, when a limit gives you a straightforward answer, well, that's your answer. Why would you go to L'Hopital's? Okay. Now, on the other hand, when x approaches negative infinity, this goes to positive infinity, this goes to 0. E to the negative large number is 0. So this is indeterminate form of the types infinity times 0. So we need to change things. Rewrite this. So limit x approaching negative infinity, x squared e to the negative x. I'll take that e to the x to the denominator. Write it e to the negative x. Now what happens? When x is approaching negative infinity, this approaches positive infinity. So denominator approaches positive infinity. Numerator, of course, approaches positive infinity. So that's infinity over infinity type, indeterminate form. So you apply L'Hopital's rule. Numerator derivative is 2x. Denominator, all I get is negative e to the negative x by chain rule. Okay. Derivative of e to the anything is itself and then chain rule. Now you see, this is again a negative infinity and this is a negative infinity overall. So you still need L'Hopital's. So take derivative of the top, that's 2. Derivative of the bottom, that's e to the negative x. Move it up. When x is approaching negative infinity, this one goes to 0. So the product is 0. All right. Now we'll come to indeterminate differences in our next video. Until then, bye.